Okay. So for today's goal, we're going to be working something a little bit different. But from yesterday's project, we were working on expo authentication with React Native and with Firebase, and just to get the Google sign-in working. And so while I was off camera, did indeed get to get this working. And I was successfully able to both get the sign-in and also sign in with email and password working, and also persistency, like session persistency working for signing in. So we know when the user is signed in and when they're signed out, stuff like that. So I'm just gonna give that like a little demo here and see how it's working. We switched from the Expo Go app to the development build because the Expo Go app doesn't support Google sign-in or the React Native Firebase dependency. As you can see, we just have a simple login page, and it goes straight to the sign-in page, even though our layout does have an index, but this index is nested where it can only be accessed after we do the whole the whole signing in process and then register the user. I don't know why my brain just blank there for some reason. So we can sign in with Google. I'm going to use my own Google account as a test user. Signed in successfully, and here we can sign out, and good. We're all good. This is super cool. So we're gonna do a little bit of a change of pace today. Instead of working on the mobile app development that I've been doing for the past few days, instead we're gonna go into more data science. I know this series is called Code With Me Until I Get a Job, which I do. I am really trying to get a job. I'm also looking for stuff with AI and stuff with data science, so that's what we're going to do today. A little background on this project right here is I am playing around with the GPT API or the OpenAI API and using GPT-4 4.0 to check out its multimodal performance, meaning how well does GPT perform when we're inserting both images and text and stuff like that, and just see how accurate it is in terms of sentiment analysis. So some previous work I did before today was I scraped a bunch of Yelp data from the Yelp open data. Basically paired a bunch of ratings with their star value, and also with picture sentiment, which are just a bunch of photos that I found online with different sentiments of people eating at restaurants. The length of the review by like character count, and then the number of stars that it was given, and the number of images that we pulled from that we did indeed, that we pulled from the API. So once we did that, we paired up the different combinations of the short, longs, and different star reviews with the images and inserted it into GPT. Should be here. Should be in Yelp GPT analysis. Just told it, hey, ChatGPT, please provide a sentiment score for 1 to 5, where 1 is very negative, 3 is neutral, 5 is very positive, and explain the reasoning in detail based on the images and the text and the analysis, just to see how we rate the different texts. So I then compiled a data set, right? And then extracted all the perceived sentiments away from it. I think we're definitely going to need ChatGPT today. Because just asking a few questions, or maybe Copilot. But one of the two. So you can see that you guys can see that extracted the perceived sentiment, and now we're just gonna do a little bit of data analysis and data wrangling on the perceived sentiment, just to see where GPT differs from the different from the actual star values. Well, I guess this is just a small sort of metric. It's not going to be completely accurate on how GPT performs. So right off the bat, we plotted two bar plots. We did some uniform sampling for the star rating and the count of the star ratings from the actual data set. And we can see that the perceived sentiment score, the distribution is not the same. And I think it's not expected to be the same, because for some samples we have like negative images paired with positive sentiments, and then for other ones we have negative sentiments paired with positive images, so you never know. And then some of them are neutral, and everything in between, stuff like that. So I think it's not unusual that we're seeing this, and I just wrote down some questions that we could go through just to see truly where everything lies. So we're gonna look at where the perceived sentiment score differs from the star value. Perceived sentiment score. First, we're going to want to filter the data frame. Actually, first let's just run all the cells above. Run all the cells above, and then go ahead and do what we're going to do. I gotta make sure oh no, it's already selected, so that's okay. Want to filter. Have data frame with columns. What columns do we have? Star, length, picture count, picture sentiment, review text, images, and perceived sentiment. I want to filter only the results perceived sentiment differs from the star rating. Perceived diff, data perceived sentiment, data of star. Okay, we have the cube now. Interesting. Okay. Don't know what it's running, but we shall see. Okay, it ran. Good. Oh, oops. I gotta turn this setting on. There is a setting where, yeah. Okay, so then of these filtered differences, just want to plot the distribution of the star values to see where they differed exactly and how they differed. receive diff of star, right? Then we have to say bins, the bins value, range. Let's do 5 bins. Right. So what are we seeing? So again, okay, so what it seems like is the distribution of the star rating. Okay. Kind of lost here. I want to display investigating the samples where the perceived sentiment does not equal star review versus GPT. The distribution of the star rating is still relatively uniform, but we see there is greater frequency of more negative or more positive, leading me to believe that the perceived review is probably weighed one modality greater than the other, right? Okay. Pair plot. Scatter plot. I think I want to. I actually want to. Okay, so I actually want to plot a scatter plot. Okay, yeah, this is exactly what I need. Let us plot a scatter plot to see where the samples are actually differing. So plt.scatter, right? X equals samples review text is not gonna have a hue. But alright, so let's just no hue. PLT.title, scatter plot of pairs, star perceived sentiment. Right, then PLT.x label is going to be the star rating or review. And then the PLT.y label is going to be the perceived sentiment score 1 through 5. PLT.grid. There's only 7 samples where the star rating disagreed with the... Wow, that is impressive actually. Wow. Out of 135 reviews, only 7 differed in score. Wow. That is very cool. Which could be by chance, you never know. However, the differences we do see. Is there a trend? There's kind of like an upwards trend, meaning that so 4 3 2 3 2 1 4 5. Well, see points in the top left. Different samples. They don't differ by more than 1. It's really good to see, honestly. Can't say much more than that, I guess. Okay, let's see. Let's check out, instead of where these differ, let's check out an example where the samples we had like a measured difference. So star value, so positive review, negative image. Last category is going to be distribution of the perceived sentiments based on short, medium, long reviews. Okay. Yeah, you could do that. Should be easy. Okay, so pause neg, pause rev, neg im. guess we can also make a correlation plot for all the I don't know if that really help. Data or data of star greater than or equal to 3 and data of where's picture sentiment equals to negative. Is it capital? Yes, it is. How many? Ooh. Did I do this one? Okay. Let's just do geo.describe. Count 27 samples. The mean of the star count is 4. Minimum is 3. Let's check out the distribution of the star count. And the distribution of the perceived sentiment is also 4. So generally just takes the, really can't tell how much it's taking the This is interesting. Okay. Dang, where's the copilot? His plot. We're gonna do pause, rev, neg, im, stars. I think it's just star. Invisibles range 1 to 5. KD is false. Right? And then color. Let's do this light blue again for the sake of continuity. Title, distribution of star reviews for positive reviews with negative image sent. But we have to say that. Okay, this data of image count, picture count. Should probably design this better, to be honest. Okay, good. We removed 9. Oh my gosh. Well, this is even worse. But anyways, the point was I removed all the pictures that, or all the samples in which there were no pictures, or else it wouldn't take the pictures into account, you know? It's that simple. Qt.x label, star, oh wow. I think we need a bar plot. We just need the bar plot instead of the his plot. There we go. All right. That is. Uh-oh. That's all I control. That's all. Put it in X. Dummy me. 3, 4. Oh. Sorry, we shouldn't be interested in the star values. Oh, really? I didn't see this on the... This is more interesting, actually. This is more interesting. So you can see that there isn't a uniform distribution. The star values have equal distribution between 3, 4, 5 star value. Let's do that scatter plot again. That's probably, that's a good plot. I like that plot. But we know guaranteed that it is taking in some sort of opinion of an image. 4, 3, 4, 3, 3, 3, 3, 3, 4. Okay, so 4, 5, 5, 5, 5. So this is telling me I want to look at this exact sample. Let's take a look at this exact sample where the star is a 3 and the perceived sent being 2. What sample is that? Oh wait, we can just, what do we filter? Div. Right, so the sample div goes pause, rounding in, where the star rating is a 3. And there's 2. Okay. How do I print sentiment analysis as a Jupyter notebook output in a code format? Oh wait, we still need this tab. Come on, ChatGPT. Alright. From Oh. The string is what? Oh, no way. Okay, so I didn't even have to do this, I don't think. Wow. That was not what I was expecting. Oh. It's that simple. Okay, so based on the review that the associated images, I would assign a sentiment score of 2. Reasoning. The reviewer expresses strong dissatisfaction with the... Huh? I guess 3 stars. Okay. I'd assign a sentiment score of 2. Overrated, specifically mentioned way overcooked despite ordering medium rare. Disappointed with the food quality. The phrase not worth the price suggests that the reviewer feels they did not receive good value. While the reviewer mentions that the seafood jambalaya was decent, this is overshadowed by the overall negative experience. Okay, now let's print out the images. Let's just display the image that comes along with this. cannot embed the... What does that mean? Oh, it is not even a list. There's some code to convert this to a list. Where's the code to convert it to a list? Import used. Okay, shrimp. I think this is the outside. More shrimp. This is the interior. Angry person eating. Okay, cool. Now what's the rest of this? Reviews say the third image shows fried shrimp. Oh, image analysis. The first image shows shrimp, which could be related to seafood jambalaya. However, the context or taste of presentation does not significantly enhance the positive sentiment. Okay. So level 3 reviews like negative, I guess. So it's good to see that GPT is taking in the opinion of taking into account all the images in their sentiment analysis. And I think that's where I'm gonna end it off today. Today we just did a little bit of coding with a little bit of data science, a little bit of plotting, just some simple plots. Thank you for watching.